Hey everyone, and welcome to our deep dive on AWS system design.
Sounds exciting.
Yeah, it seems like everyone's buzzing about this topic lately, and we wanted to really unpack it.
Definitely.
We'll be looking at system design on AWS as our main guide for this deep dive.
Great choice.
Yeah, this source is awesome because it covers a lot of ground, from those fundamental concepts to practical tips and even real-world AWS examples. So,
I like that.
yeah, by the end of this deep dive, you'll have the knowledge to confidently tackle those AWS system design projects.
And feel prepared for those tough technical conversations.
Exactly, you'll be able to hold your own.
I like that.
So where do we even begin with something as big as system design?
Well, this source really stresses the importance of understanding the core building blocks.
The foundation.
Yeah, exactly. Like maintainability, scalability, fault tolerance.
All the essentials.
Yeah, you really need a solid grasp of these concepts before diving into the specific AWS services.
It's like they're saying, hey, hold on, before you get to the fun stuff. Let's make sure you've got a strong base.
Absolutely.
And I love the analogy they use comparing system design to balancing a seesaw.
Oh, that's a good one.
Yeah, it really highlights those constant trade-offs we have to make.
Right, like cost versus performance.
Yeah, or consistency versus availability. It's always a balancing act.
Always.
And speaking of balancing acts, the source also points out those common fallacies in distributed system design.
Oh, yeah. Those assumptions that can trip us up.
Exactly, like assuming the network is always reliable.
Oh, that's a classic one.
Or thinking our system structure won't ever change.
Right, or that there's only one administrator to worry about.
Have you ever fallen into one of those traps in your work?
Oh, absolutely.
Yeah.
I think we've all been tempted to think, oh, the network will be fine.
Yeah, and then
Reality hits.
you need a backup plan.
Exactly. It's a good reminder to design for the unexpected.
For sure.
So once we have our foundation in place, the source then takes us into a critical piece of any system data storage.
The heart of it all.
Yeah, it covers various options, including block storage with EBS file storage with EFS.
And of course, everyone's favorite object storage with S3.
S3 is so versatile.
It really is.
And this source emphasizes that understanding those different S3 storage classes can really impact your costs.
For sure, you've got standard for that frequently accessed data IA for infrequent access, and then the Glacier variations for long-term archiving.
It's all about picking the right tool for the job.
Right, and saving a ton of money in the process.
Exactly, and it's not just about the cost. Either choosing the right storage class also impacts how quickly you can access that data.
That's a good point.
For instance, if you need to restore data from Glacier Deep Archive, it could take several hours.
So plan ahead.
Yeah, you really need to think about your access needs.
And here's a fun fact about S3 that blew my mind. Did you know that S3 objects can be huge, like up to 5 terabytes? Huge.
That's massive.
It's like storing a library of movies in a single S3 object.
I hadn't thought of it like that. That's amazing.
It opens up a world of possibilities.
It does.
But of course, with great power comes great responsibility.
Always.
And the source reminds us that no matter how we choose to store our data, security is absolutely paramount.
Security is always top of mind.
It touches on access control lists and bucket policies, emphasizing that data protection is integral to system design.
It's not an afterthought.
Definitely not.
So we've covered data storage, but what about the engines that power our applications databases?
Database time.
Yeah, the source covers both relational databases like RDS and Aurora and non-relational options like DynamoDB.
Good mix.
Yeah, it's fascinating to see the comparison between MySQL and PostgreSQL, those two popular choices for relational databases.
Yeah. What does source say about those two?
Well, it points out that MySQL often shines in read-heavy scenarios, while PostgreSQL might be a better fit when you're dealing with lots of write operations.
So choosing the right tool for the type of workload.
Exactly.
And speaking of tools, the source also delves into the world of NoSQL databases with a focus on DynamoDB.
DynamoDB is a popular choice.
It's a key value store known for its flexibility.
And that flexibility comes from its schemaless nature.
Meaning
You don't have to define a rigid structure for your data up front.
so it's like having a database that can adapt and grow alongside your application.
Precisely. That's a great way to put it.
But I can't help but wonder, isn't there a trade-off when it comes to this flexibility? The source mentions the CAP theorem, suggesting you can't have it all: consistency, availability, and partition tolerance.
Right. The CAP theorem, it reminds us that we have to make strategic choices based on our application's specific needs. So do we prioritize having the most up-to-date data all the time, consistency?
Even if it means...
Even if it means sacrificing some availability during network partitions.
Right, or do we go the other way and prioritize availability?
Keeping the system up and running.
Potentially serving slightly outdated data.
Yeah, it's a tough call.
It is. There's no one-size-fits-all answer.
And that's where careful system design comes in.
So we've got our data stored securely, and we've chosen the right database for our application. But what about speed?
Speed is key.
I'm guessing this is where caching comes in.
Absolutely. Caching can significantly improve performance by storing frequently accessed data closer to the user.
Makes sense.
And the source goes even deeper, explaining different cache eviction policies like LRU, MRU, and LFU.
So it's not just about storing everything in the cache.
Right. You need to be strategic about which data gets cached and for how long.
To make it relatable, think of a popular e-commerce website. Instead of hitting the database every time someone views a product page,
You can cache those pages.
they load super quick.
Exactly. Nobody wants to wait forever for a page to load.
Especially not these days.
And to take caching to a global scale, we have CDNs, content delivery networks.
Ah, those are like a network of servers around the world.
Exactly, ensuring that users everywhere get lightning-fast access to your content.
So we've got storage databases and caching covered. Those are some key pieces of the puzzle.
They really are.
But what about handling a sudden surge in traffic or preventing a single server from becoming a bottleneck?
That's where load balancing comes in.
Load balancing to the rescue.
Yeah. The source explains how load balancers distribute traffic across multiple servers.
So no single server gets overwhelmed.
It's like having a traffic cop directing cars to different lanes, ensuring a smooth flow.
That's a good analogy.
And the source dives into those different types of load balancers, too.
Like layer 4 and layer 7?
Yeah, layer 4 works at the transport layer, making decisions based on IP addresses and ports. While layer 7 operates at the application layer, taking into account things like HTTP headers and cookies.
So it's about choosing the right load balancer based on your application and traffic patterns.
Exactly.
But distributing traffic is just one part of the equation. What about maintaining user sessions?
Right, ensuring a consistent experience.
As users move between servers.
Session persistence is key.
So if someone adds items to their shopping cart,
That information is retained.
even if they're routed to a different server.
Exactly.
Yeah.
It's all about making that user experience seamless.
And with all this talk about servers and traffic, we can't forget about the language they use communication protocol.
Right, those essential protocols like TCP, UDP, and HTTP.
Yeah, I've always been curious about those HTTP status codes, like the infamous 404 error.
Oh, yeah.
They're not just random numbers, are they?
No, they convey valuable information about what's happening with our requests.
It's like a secret language between the browser and the server.
And the source also delves into that distinction between synchronous and asynchronous communication.
So synchronous is like a real-time conversation on the phone,
Yeah.
while asynchronous is more like sending an email and waiting for a reply.
That's a good way to think about it.
Choosing the right model depends on the situation.
Exactly.
So we've covered a lot of ground RDA storage databases, caching, load balancing, and communication protocols. It's amazing how all these pieces fit together.
It's like a complex puzzle.
What's next in this AWS system design journey?
Well, let's talk about containers.
Containers, they've revolutionized how we build and deploy applications.
They have. And the source provides a great overview of Docker and Kubernetes.
I'm still trying to wrap my head around containers.
Think of them as lightweight, portable packages that contain everything your application needs to run.
Like self-contained mini servers.
Exactly. And unlike virtual machines, which need their own operating system, containers share the host operating system's kernel.
Ah, so they're much more efficient.
Much more efficient and faster to start up.
That sounds amazing. But how do we manage all these containers?
That's where Kubernetes comes in.
Kubernetes, the container orchestrator.
Exactly. It manages the deployment, scaling, and networking of your containerized applications.
So it's like the conductor of an orchestra, making sure everything works in harmony.
Precisely.
And the source even encourages us to consider whether containers could simplify our own development workflows.
It's a question worth pondering as we continue our deep dive into AWS system design.
It definitely is.
We've really laid a solid foundation, haven't we?
Yeah, exploring those key system design concepts, the ones that are crucial for building those robust and scalable systems on AWS.
Absolutely. But now it's time to shift gears and dive into the world of AWS services themselves.
Let's get practical.
Yeah, let's see how these concepts come to life.
I'm excited for this.
So we've already touched on some storage options like, S3, EBS, and EFS.
The basics.
But now let's explore those database services.
Database time.
AWS offers a variety of managed database services,
Yeah.
to cater to different needs.
So many options.
Yeah. For relational databases, we have Amazon RDS and Aurora, providing managed instances of popular engines like MySQL, PostgreSQL, even MariaDB.
It's like having a dedicated team of database administrators without the overhead.
Right. AWS handles all that heavy lifting, provisioning, patching, backups.
So we can focus on the important stuff.
Yeah, your data and your applications.
And what about for those NoSQL needs?
Well, Amazon DynamoDB comes to the rescue there.
DynamoDB, a fully managed key value store.
It delivers incredible performance and scalability.
I remember the source mentioned some important limits per partition for DynamoDB.
Oh, right, like 3,000 read capacity units and 1,000 write capacity units per second.
And a maximum storage of 10 gigabytes per partition.
Yeah, it's a good reminder that even with managed services, we still need to understand those underlying limitations.
To avoid those bottlenecks.
Exactly.
But to enhance performance, especially for those read-heavy workloads.
AWS offers DynamoDB Accelerator, DAX.
DAX acting as an in-memory cache.
It can really speed things up.
Caching is key, isn't it?
Absolutely. It's all about reducing the load on those databases.
Stoving up that frequently accessed data from a faster, closer source.
And speaking of caching, the source also covers Amazon Elasticache.
Elasticache, what's that all about?
Well, it offers managed instances of those popular caching engines, like Redis and Memcached.
So it's like giving our applications a turbocharged memory boost.
Precisely.
But the world of databases on AWS doesn't stop there, does it?
Oh, no, not at all. We also have Amazon DocumentDB.
DocumentDB.
A fully managed document database service that's compatible with MongoDB.
So if you're already comfortable with that MongoDB API.
And you're looking for a scalable and highly available document database solution on AWS.
DocumentDB could be a great fit.
And then there's Amazon Neptune. A purpose-built graph database service, designed for handling highly connected data.
Think social networks, recommendation engines, fraud detection.
Exactly. All those applications that thrive on understanding relationships between data points.
And for those dealing with massive amounts of time series data.
We have Amazon TimeStream.
TimeStream.
It's optimized for storing and querying time-stamped information.
Like IoT sensor data analysis or financial market tracking.
It's like having a time machine for your data.
I like that analogy.
And if you need a powerful search and analytics engine for your data.
There's Amazon OpenSearch service.
It provides a managed Elasticsearch and Kibana service.
Perfect for log analytics, full-text search, and more.
Many options.
It's like having a super-powered search engine at your disposal.
Now let's move from data to the world of networking on AWS.
Networking, the backbone of it all.
The source provides a great overview of Amazon VPC, your own private network in the cloud.
It's like carving out your own little slice of the AWS cloud.
Yeah, where you control network traffic according to your specific needs.
And of course, security is paramount in any network environment.
Absolutely. AWS provides tools like security groups and network access control lists, NACLs.
To govern that traffic flow within your VPC.
Security groups act like firewalls for your EC2 instances.
While NACLs provide an extra layer of security at the subnet level.
Layers of defense are key.
And for connecting your VPC to the internet.
We have internet gateways, IGWs.
IGWs, they provide a secure gateway for traffic to flow between your VPC and the public internet.
Think of it as the front door to your VPC.
Controlling what comes in and what goes out.
And if you need to give instances and a private subnet access to the internet.
Without exposing them to public IP addresses.
That's where NAT gateways come in.
NAT gateways acting as intermediaries.
Enabling instances to initiate those outbound connections.
While keeping their private IPs hidden from the outside world.
Like a bodyguard for your private instances.
And for connecting different VPCs together.
We have VPC peering.
VPC peering establishes a private connection between those VPCs.
Allowing traffic to flow seamlessly.
As if they were part of the same network.
And for those larger scale networking needs, there's AWS Transit Gateway.
Transit Gateway acting as a central hub.
For connecting VPC's on-premises networks, even other AWS accounts.
It's like Grand Central Station for all your network traffic.
Now, once we have that network infrastructure in place, we need a way to distribute incoming traffic to our applications.
Load balancers.
Exactly. AWS offers those different types of load balancers.
Like the classic load balancers, application load balancers, and network load balancers.
It's all about choosing the right tool for the job.
Based on your specific needs.
And let's not forget about Route 53.
Route 53, AWS's highly available and scalable DNS service.
It plays a crucial role in directing traffic to the right resources.
Based on those domain names.
It's like the phone book of the internet.
And for API-driven applications,
We have Amazon API Gateway.
API Gateway acting as a front door for our APIs.
It handles request routing, authentication, throttling, monitoring all those critical tasks.
Ensuring smooth and secure communication.
And finally, we have Amazon CloudFront.
CloudFront, AWS's Content Delivery Network CDN.
It accelerates content delivery to users worldwide.
By caching content at those edge locations.
So no matter where your users are, they get the fastest possible experience.
Wow, AWS offers such a comprehensive suite of networking services.
It really does, from secure private networks to efficient traffic distribution and global content delivery,
It's amazing how these services work together.
to create that robust and scalable network infrastructure.
Now, with our data securely stored and our network humming along,
Let's explore the compute services.
the heart of our AWS system.
The source dives into Amazon EC2, the workhorse of AWS.
EC2, those virtual servers or instances that run our applications.
It offers incredible flexibility, different instance type sizes, operating systems, and more,
It's like building your own custom servers in the cloud.
without the hassle of managing physical hardware.
And remember those different EC2 purchasing options?
On-demand instances, reserved instances, and spot instances.
It's all about optimizing costs and performance based on your needs.
And for containerized applications,
There's Amazon ECS,
a fully managed container orchestration service.
so we can run those Docker containers without managing the infrastructure.
And for those serverless architectures,
There's AWS Lambda.
you can run code without provisioning or managing servers.
It's like magic.
And for Kubernetes enthusiasts,
There's Amazon EKS,
a managed Kubernetes service.
simplifying the deployment and management of Kubernetes applications on AWS.
But amidst all this talk about compute services,
We can't overlook monitoring and logging.
right, Amazon CloudWatch provides those essential tools.
For keeping a watchful eye on our AWS resources and applications.
Like a comprehensive dashboard for your AWS environment.
Collecting logs, setting alarms, and visualizing metrics.
And speaking of security, we have AWS Identity and Access Management, IAM.
IAM, the security guard for our entire AWS account.
Exactly, controlling who has access to what,
It's all about implementing the principle of least privilege.
granting only the necessary permissions to minimize those risks.
And for managing user authentication and authorization for our applications.
There's Amazon Cognito.
Cognito lets us create user pools, manage signups, and sign-ins even integrate with external identity providers.
It's a powerful tool for handling user identities.
And controlling access to our applications. We've covered so much ground, haven't we, from those core concepts to practical examples with a whole bunch of AWS services.
It's been quite a journey, for sure.
I feel like we've really built up a solid understanding of how to create those robust and secure systems on AWS.
Definitely, but there's always more to discover.
That's right. And this source doesn't stop there. It takes us into the world of big data and analytics.
Big data, it's a hot topic these days.
It really is. And the source introduces us to Amazon EMR.
EMR, a managed Hadoop service that simplifies processing and analyzing huge data sets.
It's like having a supercomputer at your fingertips.
Yeah, crunching numbers and extracting insights from all that data.
But what about real-time data analysis? Data that's constantly streaming in.
That's where Amazon Kinesis comes in.
Amazing.
Yeah, it provides a whole suite of services for collecting, processing, and analyzing streaming data.
In real time.
Exactly.
So it's like a pipeline for our data capturing, processing, and extracting insights as it flows through the system.
It's a powerful tool for sure.
And when it comes to storing and analyzing those huge amounts of data,
Amazon Redshift is a game changer.
Redshift.
A serverless data warehousing solution that offers petabyte-scale storage.
That's a lot of storage.
It's optimized for high-performance analytics.
So no more managing infrastructure headaches.
Exactly.
And if we want to query data directly in S3 without setting up or managing servers,
Amazon Athena can help with that.
Athena, a serverless query service that uses standard SQL.
It's like having a data analyst on demand ready to answer your questions.
This opens up so many possibilities for data exploration and analysis.
It really does.
And for those exploring machine learning,
Amazon SageMaker is a must-have.
SageMaker providing a whole set of tools for building, training, and deploying those machine learning models.
It's a comprehensive platform for all your machine learning needs.
This source has really showcased the vast capabilities of AWS.
It has. We've only scratched the surface.
There's always more to learn.
Exactly. This source is like a roadmap, guiding us towards building robust, scalable, secure systems on AWS.
And it encourages us to go deeper into those specific use cases.
It brings it aligned with our projects and interests.
It's been an incredible journey exploring AWS system design with you.
I agree. We've covered so much.
I feel like we're equipped to tackle those AWS projects with confidence now.
And hold our own in those technical discussions.
Absolutely.
As we wrap up this deep dive, I want to leave you with a thought-provoking question.
I love those.
Imagine you're building a real-time ride-hailing application like Uber or Lyft.
Okay.
What AWS services would you choose to handle that constant stream of ride requests?
Track driver locations and provide real-time updates to those users.
It's a challenge to put all this knowledge into practice.
To think like a true AWS system designer.
Precisely.
Well, thank you so much for joining us on this deep dive into AWS system design.
It's been a pleasure sharing this journey with you.
Remember, continuous learning is key in the cloud world.
Keep exploring, keep experimenting.
And keep building amazing things on AWS.
Until next time.